Hello students, welcome to EPG Pathshala. I am Dr. Nimisha Jadon from School of Studies Environmental Chemistry, Jivaji University, Gwalior. Today we are going to discuss about the analysis on control methods of NOx, that is oxides of nitrogen, under the paper of environmental analysis. The learning objective of this module included the sources and effects of various oxides of nitrogen, their analysis method and their control methods. So first of all, we are going to discuss about the role of oxides of nitrogen as a pollutant in the air. The diatomic molecular nitrogen is a relatively inert gas that makes up about 80% of the air that we breathe. The chemical elements nitrogen as a single atom can be reactive and have ionization levels. However, the oxidation of nitrogen by the bacteria, lightning, organic protein decay and the high temperature combustion and the chemical processes causes the appearance of nitrogen in a variety of the compounds. The most important because of health effects and the reactivity are the important oxides of nitrogen, including the nitric oxide, that is NO, nitrogen dioxide, that is NO2, ammonia NH3 and to a lesser extent of N2O, that is nitrous oxide. Now we are going to discuss about the various types of oxides of nitrogen. The number one is the nitrous oxide. It is also known as laughing gas. The nitrous oxide is a colorless and odorless gas, has been used as an anesthetic. It is present in the atmosphere in concentrations averaging out 0.25 ppm, with the reference of Chung in 1963 and Batts and Hayes in 1967, and there are no direct pollutant sources of nitrous oxide, although it may be an indirect and minor product of nitrogen dioxide photolysis with the sunlight and hydrocarbons. The second oxide of nitrogen is ammonia. As an industrial emission, ammonia is produced mainly from the coal and oil combustion, but natural production from biological generation over land and ocean is many times greater than that from anthropogenic sources, like it is from 250:1 ratio. Then the ammonia's importance significant role in atmospheric reactions in both the nitrogen and the sulfur cycles. Nearly three-fourths of the ammonia is converted to ammonium ion condensed in droplets or the particles. These aerosols are then subject to the physical removal mechanisms of coagulation, washout, rainout and dry deposition. The third one is the nitric oxide or nitrogen dioxide. The nitric oxide is a colorless, odorless gas, is formed naturally from the nitrates in various materials by bacteria and then is oxidized to nitrogen dioxide. Have reported very hazardous condition for farm workers near closed silos where NO is converted to NO2, that is nitrogen dioxide. The bacterial production has resulted in toxic concentrations of several hundred ppm of nitrogen dioxide. Now here we are discussing about the various types of oxides of nitrogen and their properties. The number one is nitrous oxide, that is denoted by N2O. It is a colorless gas, water soluble. Then NO and N2O2 is nitric oxide and dinitrogen dioxide. It is a colorless gas, slightly water soluble. Then dinitrogen trioxide, it is a black solid, water soluble. Then NO2 or N2O4, that is nitrogen dioxide or dinitrogen tetraoxide.
It is a red-brown gas and highly soluble in water. Then dinitrogen pentaoxide, that is N2O5. It is white solid and very soluble in water.
Nitrous oxide, that is N2O, NO, that is nitric oxide, and NO2, that is nitrogen dioxide, are the most abundant nitrogen oxides in the air. The N2O, that is also known as the laughing gas, is produced abundantly by the biogenic sources such as plants and yeast. The N2O is an ozone depleting substance which react with ozone in both the troposphere and in the stratospheric region. The N2O is also considered as a greenhouse gas. So the NO2 is present in the atmosphere and in the acid rain. It is a combination of both type of natural processes like greenhouse and the acid rain. Both the processes are triggered out by the presence of oxides into the nitrogen. The main sources of nitrogen oxides in the atmosphere included the automobile exhaust, then the electric power plant boilers, industrial boilers, incinerators, gas turbines, reciprocating spark ignition, then diesel engine in the stationary sources, and the iron and steel mills. Other than these sources, the minor other sources of oxides of nitrogen in the atmosphere included the cement manufacturing companies, then glass manufacturing, petroleum refineries, and nitric acid manufacturing. Biogenic or the natural sources of nitrogen oxide including the lightning, forest fires, grass fires, trees, brushes, grasses, and the yeast are the sources of nitrogen dioxide into the ambient air. In all the combustion process, there are three opportunities for the NOx formation, that are the number one is thermal NOx, number two is the fuel NOx, and number third is the prompt NOx.
Now, here we are discussing about the analysis methods of oxides of nitrogen. The method is frequently used to determine the nitrogen oxide in the atmospheric air is known as modified Jacobs and Hutchinson methods. In this method, the ambient nitrogen dioxide is collected by bubbling air through a solution of sodium hydroxide and sodium arsenide. The concentration of nitrite ion produced during sampling is determined colorimetrically. By reacting the nitrite ion with phosphoric acid, sulfonamide, and N-naphthyl ethylene diamine dihydrochloride, that is NIDA, also known as by the name of NEDA, that is NIDA, and then measuring the absorbance of the highly colored azodite that is prepared by the reaction of oxides of nitrogen with the ethylene diamine dihydrochloride at 540 nanometer.
Now the instrument are the equipments used for the analysis of NOx in air, including analytical balance, vacuum pump, atmosphere across the flow control device, calibration flow measuring devices, absorber, spectrophotometer for the analysis, and some glasswares.
Now the reagents are used for the analysis of nitrogen spectrophotometrically, including distilled water, sodium hydroxide, sodium arsenide, absorbing solution, sulfonamide, then N-naphthyl ethylene diamine dihydrochloride, that is also known as NIDA, hydrogen peroxide 30%, and phosphoric acid 85%. The sodium arsenide here is used for the sample that are containing the high amount of chloride, and chloride interferes in the determination of nitrogen dioxide, so it is used as to remove the interferences in the determination. Then the other solutions are used including sodium nitrite stock solution, that is a concentration of 1000 microgram of nitrogen dioxide per ml. Then sodium nitrite solution, intermediate solution, that contain the concentration of 10 microgram of nitrogen dioxide per ml of solution. And finally we are preparing sodium nitrite working solution of the concentration of 1 microgram of nitrogen dioxide per ml. Now for the analysis purpose, first of all we have to collect the sample of the nitrogen oxides of nitrogen from the air sample. For that, place 30 ml of the absorbing solution in an impinger and sampling it for 4 hours at a flow rate of 0.2 to 1 liter per minute. After sampling, measure the volume of sample and transfer to a sample storage bottle.
Now we discuss here about the analytical procedure of determining NOx in the air sampler. For the analysis purposes, first of all, place 30 ml of the absorbing media in an spinger. Then connect it with the gas sampling manifold of gas sampling device and draw air at a sampling rate of 0.02 ppm to 5 ppm for 4 hours. Then check the volume of the sample at the end of sampling and then record it. Then transfer the exposed samples in the storage bottle and preserve it for the further analysis. Then prepare calibration graph as recommended in the method. Take 10 ml of the unexposed sample in the 50 ml volumetric flask and consider it as a blank. Then add 1 ml of hydrogen peroxide in each of the volumetric flask. Then add 10 ml of sulfonamide. Then add 1.4 ml of needle solution, that is N-naphthyl ethylene diamine tetraacetic acid solution, and make up to the mark with 50 ml by using distilled water. After that, keep the solution for the 10 minutes for the reaction and then set 0 of the spectrophotometer with the distilled water. Then measure the absorbance at 540 nanometer and then calculate the concentration by using calibration graph. The impurities or the absorbance due to the presence of impurities in any types of solvent is eliminated by using the blank solution, and then calculate the concentration of nitrogen dioxide in microgram per meter cube.
Now here we are discussing about the control methods of oxides of nitrogen into the atmosphere. For that, the first method is the reducing the temperature. When we are reducing the temperature of the combustion process, the emission of oxides of nitrogen control in some manners. The reducing combustion temperature means avoiding the stoichiometric ratio, the exact ratio of chemicals that enter into the ratio, so that it is essentially this technique dilutes calories with an excess of fuel, air, flue gases or the stream. When we change the stoichiometric ratio, then the emission of the oxides of nitrogen could be controlled by means of some reaction. The combustion controls use different form of this technique and are different for fuels if high and low nitrogen contents are present in the fuel. The combustion temperature may be reduced by using fuel-rich mixture to limit the amount of oxygen available, then using fuel-lean mixtures to limit temperature by diluting energy input, then injecting cooled oxygen depleted flue gas into the combustion air to dilute energy, and then injecting cooled flue gas with added fuel or injecting water or steam. The second method is the reducing residence time. The reducing residence time at high combustion temperatures can be done by ignition or injection timing with internal combustion engines. It can also be done in boilers by restricting the flame to a short region in which the combustion air becomes flue gas. This is immediately followed by injection of fuel, steam, more combustion air or recirculating flue gas. The third method of control of NOx into the atmosphere is known as chemical reduction of oxides of nitrogen. This technique provides a chemically reducing, that is, reversal of oxidation substance to remove oxygen from the nitrogen oxides. Examples include selective catalytic reduction, it is also known as SCR, which uses ammonia. The selective non-catalytic reduction that also be used for the removal of oxygen from the nitrogen oxide. All of these technologies attempt to chemically reduce the valence level of the nitrogen to zero after the valence has become higher. Some low NOx burners also are based partially on this principle. The fourth one method is the oxidation of the oxides of nitrogen. This technique intentionally raises the valence of the nitrogen ion to allow water to absorb it. This is accomplished either by using a catalyst, injecting hydrogen peroxide, creating ozone within the airflow, or injecting ozone into the airflow. The non-thermal plasma, when used without a reducing agent, can be used to oxidize the oxide of nitrogen. A scrubber must be added to the process to absorb dinitrogen pentaoxide emissions to the atmosphere. Any resultant nitric acid can be either neutralized by the scrubber liquid and then solid. The next method used for the removal of oxides of nitrogen is the combustion. The removal of nitrogen from the combustion, it is accomplished by removing nitrogen as a reactant either by using oxygen instead of air in the combustion process or using ultra low nitrogen contained fuel to form less fuel of oxides of nitrogen. Eliminating nitrogen by using oxygen tends to produce a rather intense flame. Eliminate nitrogen oxide totally if air is the quench medium. Then hot flue gas heats the air that is used to quench it, and this heating generates some thermal NOx, that is oxides of nitrogen. This method also includes reducing the net excess air used in the combustion process because air is 80% nitrogen. Using ultra low nitrogen contained fuels with oxygen can nearly eliminate fuel and prompt NOx. The next method is sorption, both adsorption and the absorption. Adsorption, the difference between the adsorption and absorption is that the adsorption occurs at the upper surface of the absorbing media, and in the absorption process the whole media is absorbs the material into it. The treatment of flue gas by injection of sorbents such as ammonia, powdered limestone, aluminum oxide or carbon that can remove NOx and the other pollutants, principally sulfur. There have been successful efforts to make sorption products a marketable commodity. This kind of treatment has been applied in the combustion chamber, flue, and the baghouse. This method uses either adsorption or absorption followed by filtration and electrostatic precipitation to remove the sorbent. The next method is the combination of these methods. Many of these methods can be combined to achieve a lower concentration of NOx than can be achieved alone by any one method. For example, a fuel-rich cyclone burner, that is method 1, can be followed by fuel burner, that is method 3, and overfire air, that is again a method 1. So this combination of these two methods can reduce the oxides of nitrogen comparative to the single one method.
Here we are discussing about the external combustion pollution prevention methods. This includes number one method is less excess air. In this method, the excess airflow for the combustion has been correlated to the amount of NOx generated. Then the second method is known as burner out of service. In this method, the multiple burner equipment can have part of an array of the burners with some burners out of service, not filling fuel, but supplying air or flue gas. This allows the burner around them to supply fuel and air to air or the flue gas flowing from the boost, that is boost is the short form of burner out of service method. Then the third one important method is low NOx burner. A low NOx burner or the LNB provides a stable flame that has several different zones for controlling the NOx release in the atmosphere. Then the next one method is the flue gas recirculation. In this method, the recirculation of cooler the recirculation of cooled flue reduces the temperature by diluting the oxygen content of the combustion air and by causing heat to be diluted in a greater mass of flue gas. The next method is known as water or steam injection. In this method, the injection of water or the steam causes the stoichiometry of the mixture to be changed and adds steam to dilute calories generated by the combustion. The next method is used, that is reduced air preheat. In this method, the air is usually preheated to cool the flue gases and reduce the heat loss and gain efficiency. Then the last one method is known as catalytic combustion. This method use of a catalyst to cause the combustion to occur below the nitrogen oxide formation temperatures that can provide a suitable means of limiting temperature.
The NOx control can be achieved by tail and control equipment. The combustion modification and the modification of operating conditions provide significant reductions in NOx, but not enough to meet regulations. For further reduction in emissions, tail and control equipment is required. Some of the control processes are selective catalytic reduction, selective non-catalytic reduction, electron beam radiation, and staged combustion. The selective catalytic reduction can be used in NOx control in the following manner. The another method of reducing the pollutant emission is to use a catalyst to achieve oxidation of fuel rather than high temperature. The catalytic combustors like natural gas, propane, and the vaporized distillate oil for gas turbine have reduced NOx emission to well below 10 ppm. Fuel and air are mixed to the desired ratio and introduced into the chamber containing a ceramic or metal catalyst. The selective non-catalytic reduction process involves the following. At high temperature up to 900 to 1000 degrees centigrade, the ammonia will reduce NOx to nitrogen without a catalyst. At ammonia, the NOx molar ratio of 1:1 to 2:1, about 40 to 60% reduction is obtained. SNR is cheaper than the SCR in terms of operation cost and capital cost. Tight temperature controls are needed. At lower temperature, non-reacted ammonia is emitted. At high temperature, the ammonia is oxidized to nitrous oxide. The electron beam radiation process is as follows. This treatment process is under development and is not widely used. Work is underway to determine the feasibility of electron beam radiation for neutralizing hazardous waste and air toxins. The irradiation of flue gases containing the NOx or the SOx produce nitrate and the sulfate ion. The addition of water and the ammonia produces NH4NO3 and NH4 whole twice SO4. The solids that are removed from the gas and are sold as fertilizers. The staged combustion process. In this process is used to control NOx can be explained by the staged combustion process has been used to reduce significantly NOx emission. In the initial stage, the combustion the air supplies to the burners is less than the amount required to completely burn the fuel. During this stage, fuel-bound nitrogen is released but cannot be oxidized. So, it forms stable molecules of harmless molecular nitrogen, that is nitrogen gas. And the other components of the fuel are also released without being fully oxidized. These include carbon particles and carbon monoxide. By adding a second stage in the air-fuel mixture, the carbon and the carbon monoxide can be burned and converting them to the carbon dioxide. The next method is overfire air injection. The primary flame zone is operated in excess of fuel to reduce oxygen concentration and additional air is added downstream. This overfire air, that is OFA, provides oxygen to complete combustion of unburned fuel and oxidize carbon monoxide to carbon dioxide, creating a second combustion zone. Because there is so little fuel in this overfire zone, the peak temperature is low. Thus, NOx formation is inhibited in both the primary and overfire combustion zones. This technique results in air staging. Here, 10 to 20% of the total combustion airflow is fed above the flame through OFA injection ports located at the topmost levels of the burner and burning solid fuel such as coal and the solid waste. The effectiveness of this system depends on parameters such as port location, number of OFA ports and their geometry, spacing, pressure drop, furnace dimension and fan capacity. The next method is post-emission control process. the combustion and the operational modification techniques that aim at reducing thermal NOx formation by reducing flame temperature are not effective for controlling fuel of prompt NOx. They do not provide adequate NOx control according to the regulatory standard. In such condition, flue gas treatment for post-emission control of NOx is applied. It is the secondary approach for the NOx control, which includes destruction of NOx by allowing it to react with other reagents, making it possible to eliminate them either chemically or biologically. Here you have shown the picture of the combustion process for the which is used for the control of NOx emission, and the gas turbine intercooling method, that is the temperature control method to control the NOx emission. In the combustion process, there is a chamber. When the gas is supplied to this chamber, the high flammable burner is burn out the fuel so that the maximum particles of the nitrogen containing is settled down at the bottom, and the flue gas is removed at the top of this burner. And in this second process, the gas turbine with the intercooling, when the gas is passes through the chamber, then the high pressure compressors are there in between. So these compressor, when we feed the fuel in between these compressor, then they are maintaining the temperature, and by maintaining the lower temperature they can reduces some part of the nitrogen oxides from the fuel, and then the exhaust gas is free from the nitrogen containing fuel.
So, in this module, we have learned about the various sources and the effects of oxides of nitrogen that is present in the air, because the chemical element nitrogen as a single atom can be reactive and have ionization level. That's why it forms various types of oxides with the reaction of oxygen that present in the atmosphere, and these oxides play a major role in the greenhouse effect and in the acid rain. So that's why it is really necessary to determine their concentration in the atmosphere. So in this module we have discussed about the determination method of NOx in the ambient air, that is a spectroscopic method, and we have also discussed here about the various control methods that are used at the fuel level or at the flue gas level, so that we can control the emission of the oxides of nitrogen into the atmosphere. Thank you so much.